Yes. Here we go. We're recording now. So double the angles. We get two of them to look at, or three actually, and that's sine 2 alpha. And you can write that 2 times sine of alpha, cosine of alpha. There's only one choice for that. That's it. And we have cosine 2 alpha. Cosine 2 alpha actually has 3 choices. It's really 1. But if you start playing with the trig identities, remember what sine squared plus cosine squared equals what? 1? So if you want to play with that, you're going to say, wait a minute, what is cosine squared equal to? If you move the sine squared to that side, you have cosine squared theta equals what? 1 minus sine squared. And you have sine squared from this one, if you solve it, equals what? 1 minus cosine squared. So that's the reason why you have 3 for the cosine, because now we start playing with the algebra. I say, you know what? Instead of a cosine squared, let me write 1 minus sine squared. So if I take the cosine squared from this, it will be 1 minus sine squared theta. And there's a minus sine squared theta here. And you end up with what? 1 minus 2 sine squared theta. The sine square?
Yeah.
Sure. If I replace the sine square with this one, guess what you're going to have? That's where the third one comes in. It becomes cosine squared alpha minus, in place of sine square, let's put what? 1 minus cosine squared alpha. So you'll have what? Cosine squared alpha minus 1 plus cosine squared alpha, which is 2 of them. And that's where the third one came from. So when they're talking about cosine 2 alpha, they always give you this, or this, or this. But that's really nothing more than playing with the math. Now tangent 2 alpha, it's 2 times tangent alpha over 1 minus, not a plus, minus tangent square alpha. That's it. That's the 3 identities I'm going to be using. I'll box them all. The sine of 2 alpha, the cosine of 2 alpha, and the tangent of 2 alpha. So let's take an example. Let's see. Let's see if the math is actually true here. Here we go. Here's the question. If cosine alpha is equal to 3/5, and I'm going to say we are in quadrant 4. I'll tell you where we are. What is find? I want to find here sine 2 alpha. That's one of the questions. Well, this is what? Sine 2 alpha. There's only one rule for that. 2 times sine of alpha, cosine of alpha. So 2 times, I don't know sine of alpha, but I know cosine alpha. So if I know sine of alpha, I'm done. How do we figure what sine of alpha is? Let's look and see what we have, yeah? Let's take a look at what we have. So we have alpha in this quadrant, in the fourth quadrant. This is alpha. And the cosine is 3 over 5. What side is the cosine? Adjacent over what? Hypotenuse. Well, it would be a negative, right? Because this is below the axis. That side has to be negative. So if I call that b, I'll go 5 squared equals 3 squared plus b squared. 25 equals 9 plus b squared. B squared equals 16. When you have a number square equal, a variable square equals a number, then that variable equals what? It's really plus or minus the square root of 16. We need to look at the picture. Is that a positive or a negative here? Negative, so b is negative 4. It's below the axis. All students or all stores take cash. Remember that? All stores take cash. All three trig functions positive here. Only the sine is positive. Only the cosine, only the tangent. All stores take cash. All stores take cash. What does that mean? All three of them are positive here. In this quadrant, S for sine. Sine is positive. Cosine is negative. Tangent is negative. In this quadrant, T for tangent. The sine is negative. The cosine is negative. And the tangent is positive. And cash, which one begins with C? Cosine is positive. The sine is negative. And the tangent is negative. So your tangent has to be negative. Your sine has to be negative. Your sine now is the opposite over the hypotenuse. What's the opposite? Negative 4, and what's the hypotenuse? 5. So let's do the math. The bottom is 25. 3 times 4? 12. 12 times 2 is 24. That's negative 24 over 25. Let me try another one. Similar to this. Find sine, or find tangent 2x if sine of x equals 0.5. Again, with all these problems, I'm sure they're looking for the exact answer. I'm going to tell you which quadrant you're in. Second quadrant. Quadrant 2. Again, quadrant 2, who's positive there? Only the sine. All stores take cash. So the cosine, the tangent should be negative. So the angle in quadrant 2, somewhere here, so there's my triangle. And it says the sine equals what? 0.5. What is 0.5 as a fraction?
1 over 2.
1 over 2. So you know this is 1 and that's 2. Notice it's positive because it's above. Now I got to find the x value. Notice since the x value to the left, it should be what? Negative. So 2 squared equals 1 squared plus x squared. 4 equals 1 plus x squared. 3 equals x squared. X equals plus or minus the square root of 3. Look at the picture, the x value. Should it be positive or negative to the left?
Negative.
Negative. So negative the square root of 3. So what are we looking for? The tangent of 2x. Tangent 2x equals 2 times tangent x over what? 1 minus tangent x squared. What's tangent x? What side? What side is the tangent? Sakatoa. T-O-A.
Opposite over adjacent.
Opposite over adjacent. Opposite is 1, the adjacent is this. So the tangent is 1 over negative the square root of 3. Over 1 minus 1 over negative the square root of 3 squared. The minus sign you can put on the top or the bottom, doesn't really matter. So when you simplify the top, it's going to be what? Negative 2 over the square root of 3 over 1 minus. When you square that, what are you going to have? What's the 1 squared? 1 over 3. It's plus because you're going to square that. So what we have is negative 2 over the square root of 3 divided by what? 2/3? 1 minus 1/3 is 2/3. So when you have division, you can change it to multiplications. Times what? 3 over 2. So that's negative 6 over 2 the square root of 3. They don't like to see a square root in the bottom. So we're going to multiply the top and the bottom by what? Square root of 3.
So negative 6, right?
Negative 6, the radical of 3 over. What's the square root of 3 times the square root of 3? 3 times the 2, 6, and the 6's will cancel each other out. Negative the square root of 3. Notice we don't even know what the angle is. We just know the sine's 1/2. I'll try one more of these. I can see from body language some of you are still not sinking in. Find, ooh, this is not nice. Find sine 4x, not 2. If tangent x is equal to negative 0.6, which quadrant? Fourth. So you're in the fourth quadrant. Let's deal with that first. Only the cosine is positive in the fourth quadrant. So we have, somewhere here, we have that angle x. The tangent is opposite over the adjacent. So negative 0.6, that's what?
6 times negative
Takes over, yep, negative 6 over 10, right?
3/5.
Which is 3 over 5, yes. So this is the 5. That's the negative 3. The hypotenuse will never be negative. That's the negative. We know if you have 3, 5, what is this angle has to be? This side. Has to be 4. But is it positive 4 or negative 4? What do you think?
Positive.
Positive because you're going to the right. So you can do c squared equals a squared plus b squared. Solve for it. You know it's a 4. Okay. How is that going to help me? Well, the only thing that comes to my mind, I can write the 4x as what? Because we don't have a 4x. 2 times 2x. Right? Twice that number. So if I do that, it's going to answer is going to be what? 2 times sine of 2x cosine 2x. 2 times sine of this, cosine of that. That's 2 alpha. That's your alpha. Now let's break this one down more. There's the 2. And what is sine 2x? 2 sine of x cosine of x times, what's cosine 2x? Which one you want to use? Any preference which one to use? Doesn't make a difference. You have 3 of them for the cosine.
Convert cosine to sine.
Cosine squared minus sine squared is fine. So if I know what the cosine and sine are, I'm done. What is the cosine of x from this picture when you look at that triangle? The cosine is the adjacent over the hypotenuse. What's your adjacent? 4. What's the hypotenuse? 5. The sine is the opposite over the hypotenuse.
Negative 5 over 5.
Now plug them in. You will have 2 times 2 times sine of x. What's sine of x? Negative 3 over 5. Times cosine of x, which is what? 4 over 5. Times the cosine squared. Take that cosine squared. What is 4 over 5 when you square it?
16 over 25.
Minus, what is the sine squared when you square that one? 9 over 25. 2 times 2? 4. So that's 4 times negative 3 over 5. 4 over 5. And what's 16 minus 9? 7 over 25. The bottom, 25 times 5 is 125 times 5 is 625. There's going to be a minus. I'll put the minus in the front. 4 times 3. 12. 12 times 4. 48. 48 times 7. 48 times 7. 336. And that's my answer. I can't simplify that. This number is divisible by 2, this is not. This number is divisible by 3, this is not. This number is divisible by 5, that's not. Unless there's some crazy number they can divide them. But I don't see one off the top of my head like they both can go into. What is it? It could be some stupid number like 30, a prime number, 31, 37 divisible by, it's possible. But I don't see an obvious one. So that's my answer for that one. So you handle the 4x as 2 times 2x, so you break it down to this, then you still take this one and break down to this, break down to that one. Yes?
Why don't you distribute the 2?
Well, when you're multiplying, it's just this times this. You don't multiply by all of them. Just like when you're multiplying 3 times 5 times 10. It's not a 3 times 5 and 3 times 10. It's 3 times 5, which is what? 15. 15 times the 10, which is what? 150. So you can't distribute that.
So the top one's in parentheses, where it says 2 times.
Yep, that's a multiplication. So you distribute that one's addition there. Like if you have 2 times 3 plus 4, then yes, you can distribute that. Now when it's multiplication inside that. So what you have here is multiplication on the inside of that. You take the answer of that, multiply it by 2. Let's see other examples we can use. Double the angle, then we'll jump to the last section. A few more examples, not like these. I'll change the direction of it. Let me find one here. Simplify. Going back to simplifying. Okay, simplify. Sine 2 theta over 1 plus cosine 2 theta. I should put parentheses on these so you know that's 2 theta here. Better, I like it better this way. Let's look at sine 2 theta. I can write that as what? 2 times sine theta cosine theta. So I'm trying to simplify. See that one here? Will be great if I can take this and do it with something minus 1. What can I do cosine 2 theta? Here's the 1 plus, in place of cosine 2 theta, I have 3 options. I don't want to add another 1 because if I put a 2 here, I can't simplify. But if I can get rid of that 1, boy, I can simplify it.
2 cosine squared.
So this is 2 cosine squared theta minus 1. Something everybody knows. Oh, nope, that tissue. Now what's going to happen to the 1 and minus 1? They cancel each other out. So I will have 2 sine theta cosine theta over cosine 2 cosine squared theta. The 2's will cancel each other out. One of the cosine will cancel once, you end up with what? Sine theta over cosine theta, which is what? That's a tangent theta. One of the cosines will cancel each other out, and you end up with the sine over cosine. Okay, let's try another one. Simplify. Where'd you go? I lost you. I was looking at a problem here and I lost it. Here we go. 2 plus cosine 2 theta over sine square theta That's it. Well, before I switch this one, let me look at that problem a little bit. The 2 is 2 over what? 1. If you're going to add fractions, what do you need? LCD, right? So do it now or do it later. Trust me, you have to do it. You don't have a choice. And that'll be what? 2 sine square, right? This is what? 2 sine square theta plus cosine 2 theta. Now maybe I can replace cosine 2 theta with something. And maybe I can lose that 2 sine squared. I'm trying to make it smaller. Maybe I can lose the 2 sine squared. Well, cosine squared is what? I mean, cosine 2 theta is not 1 minus 2 sine squared? 16, the third one. That'd be 2 sine squared theta. And replace cosine theta with 1 minus 2 sine squared theta. And the 2 sine squared cancels the 2 sine squared, so you have what? 1 over sine squared theta. What is 1 over sine squared theta? 1 over sine is what? Is that cosecant?
So it's cosecant squared?
Yep. So that's the cosecant squared theta. I'll do another one. In our book, this subject is half a page. I like when they do that. Boom. 2 examples done. I'm just looking through the book, and I honestly can tell you, I don't remember seeing some of these. So it's not like something I sat there and planned for it. What I try to do with these problems, I'll just take whatever hits me first, whatever idea, and go with it and see if anything happens. If not, I'll think of a different choice there. So this is the one. I want to simplify that. The problem is there's nothing on the board, or we discussed it as cosecant.
But cosecant is 1 over sine.
Cosecant is what? 1 over sine. So I'm going to replace the cosecant with what? 1 over sine 2x times tangent x. I'll leave this tangent x. Or I can take tangent x and write that as what? Sine of x over cosine x. So if I clean that, that's 2 times sine of x on the top The bottom is going to be what? Sine 2x cosine x. What can we do now?
Turn sine 2x.
Sine 2x, there's only one choice for that, right? So 2 times sine of x. So sine 2x can be replaced with 2 times sine of x cosine of x. Take that, multiply it by what? Cosine of x.
1 over cosine.
Yep, the 2 cancels the 2. The sine cancels the sine. When you cancel the whole thing, what's left on the top?
1.
Always a 1. One over cosine is what? Secant, that's a secant squared x. And that's double the angles quickly there. That's not the big section tonight. The big section is the next one.